Hello and welcome to Lesson 4. Before we start this lesson, what I'd like to do is to continue our exploration of how polymer processing operations make materials that are used every day worldwide. So, today, let's think about netting. Perhaps it's mosquito netting to minimise the risk of mosquito-borne disease, or the orange netting that you get alongside roadworks, or perhaps the netting that you use to fence off an area for chickens or other assorted animals to run around in. How's this material made? Well, let's find out. The sorts of netting that I'm talking about, I'm picturing there on the whiteboard. Many of you will recognise the orange mesh that appears around holes in the middle of the road or trenches in the middle of the road. Or you may even recognise the green mesh there, which is a ground stabilisation mesh in order to keep, for example, embankments from slipping. Now, historically, these meshes were manufactured from a material such as polypropylene or maybe nylon. But what we can do is we can learn a lot about how the process works by looking at the historic process with these non-biodegradables, and then we can adapt these processes looking forward to ensure that they can be used with more environmentally benign polymers. So, what we need to do is to understand the mechanics of the process that makes these products. And it might not come as a surprise to know that it all starts with extrusion. The process that I'm talking about is called the Netlon process, registered trademark, and we'll talk more about the person behind Netlon in a minute. But it's beautifully simple and it's beautifully elegant. So once you've got a polymer melt, thanks to a single screw extruder usually, what you have is a Netlon die. And we'll talk more about the design of this die in a minute, but this die is really the crux of the process and where the clever stuff takes place. Downstream of the die, your mesh emerges and is quenched in a water bath such that you solidify the polymer, and then you've got what by now is fairly familiar haul-offs and drying stages. Drying might be an infrared-based heat lamp, it might be a hot air-based system. With the orange roadworks mesh, there is a degree of orientation and stretching that's imparted into the material with this downstream processing, but that's not always the case because the mesh is a fairly functional type of product as soon as it is extruded. So the person behind this, the inventor of the process, was a chap called Dr. Brian Mercer. He was based in the UK. I believe, if memory serves me correctly, he patented the Netlon process sometime in the 1960s. And its clever bit is all in the extrusion die. So let's have a look at that in a little more detail. So the Netlon extrusion die is a wonderful piece of lateral thought, and it is an annulus that counter-rotates with slots milled in it. So let me just show you what I mean. So there on the whiteboard is an animation of this counter-rotating annulus. And the slots that are highlighted in yellow there are where the polymer melt emerges. And we can see that periodically those slots coincide, but a lot of the time that they're acting independently from one another. So if we look at the structure of a polymer mesh, there's a ground reinforcement mesh, just to remind you, what we have structurally are nodes where the two mesh strands join, and then individual strands. And so thinking about the movement of the die, those nodes are formed when the slots coincide. You've got two streams of molten polymer coming together and joining. Now, when those slots are not coincident, then you've got individual strands. But because they're always coming together and then not being coincident, and then coming together and not being coincident, you end up with a series of nodes and strands. And it's that which makes the mesh up. Now, the real Netlon dies have many, many more slots than the one I've pictured there. I've just pictured 4 for simplicity. And there's a lovely story about how Brian Mercer came up with this idea. And apparently, story has it, that he was looking for a means of trying to make these sorts of products and was experimenting quite simply with a couple of wooden rulers, just linear wooden rulers, 30-centimetre rulers. And he had cut some notches in these rulers, and he was sort of pushing them in counter motion to each other back and forth, so in a linear way the slots lined up and were independent, and just pushing mashed potato through it. And he formed a nice sort of mesh type structure with this mashed potato. But a linear die wouldn't make a great deal of engineering sense and would be quite difficult mechanically. But of course, if you wrap that around on itself, you just get two annuli that rotate instead, which is far more mechanically simple and a lot cheaper to make. So there we have the Netlon process to make polymer meshes. If you'd like to see this in action, have a look at the video that I've linked there, then I've put that link as well in the show notes, and it shows a really beautiful, quite small scale mesh being extruded into a water bath.